Hey guys, it's Coated Steel, and I'm bringing you your second to last tutorial in this series. Guys, instead of cutting it off at this episode, I looked at the number. There's 20. 20 is an even number. I don't want to end on 19. That's just kind of odd. So we're going to cover two more things before we end this. We're actually going to push the random next to the next tutorial, but what we're going to cover today is more on data types from earlier. So what I'm going to do is I'm going to show you guys about what a bool does. So a bool is basically a boolean number is either a 1 or a 0. It can't be anything else because it's 1 bit. A bool is 1 bit. It can only be a 1 or a 0. So I'm going to show you guys that. I'm going to type in a 0, okay, and then I'm going to go ahead and say we're going to go our printf, and we're going to go put the %d like we usually do for formatting, and we're going to say, and we have to name it I. So, okay, yeah, it's a 0, but I could have done that with an int too, is what you guys are probably thinking. So I'm going to show you a 1, just to show you that it'll do a 1 too. But again, that doesn't really do us much good right now, right? Because I could do that with, I could represent that with an int before, no problem. I could have just typed int and set it equal to 1 or 0, and it would have read it just the same. So what's the difference between a bool and an int? Well, I'm going to show you guys that. Let's say I go to 2. What is going to happen when I go to 2? It actually took a 2. So that's interesting. Hang on a second here. But if I go to 9, I want to see what this thing's max number is here. 9. Oh, because I have it in int. Duh. My bad. It should not have taken 2. There we go. Now it will not take a 2. See, this is what I was trying to prove until I made a stupid mistake. Any number beyond 1 will return a 1. So if it's a 2, it'll return a 1. If it's 1047, it'll return a 1. If it's 9,764,332, it's going to return a 1. It doesn't matter what number. So any number greater than 1 becomes 1. Any number that's 0 is 0. I think if you go negative, it's still 0, but I have not actually tried. I don't remember for sure. Nope. So if you go negative, it assigns it to a 1, and I should have known that because when the way numbers are stored. So we'll talk about number storage at a different time. But so 0 is the only way to represent 0, and 1 can be represented by negative numbers or positive numbers, but they're going to get converted to a 1. So you might as well just stick with 0 and 1. There's no reason to go outside of that. So why did I show you guys this? Well, sometimes we want to talk about true and false. We don't want to talk about, 1 or 0 or 2 or 3 or 4 or 5 or 6 because we don't care, right? Like when we typed an if statement before, we went ahead and we said if num is equal to 9, do some stuff, right? Well, this is a different way of doing that now. Now that we're using a bool, we can go ahead and do something like this. We can say, instead of doing that, like num is equal to whatever, num is equal to 1, or instead of doing num is equal to 1, or the I is equal to 1 in this case, okay, and then it will return a 1. Well, why don't we just do this? I. And then put within here print f bool is 1. See, basically this makes things a lot easier for us in the long run. Like if you're going to try to shorthand code, you can go ahead and you can write your conditions outside of the if statement and then bring them into the if statement here like this as I, and now this code will execute because bool is 1, See, bool is 1, but because I didn't do a new line, it's going bool is 1, 1. So, but I can also do this. Bool is 1, so if you guys remember the not operation, I believe I explained this in a previous tutorial, this will take the not of 1, so this code will not execute now, and it'll just go to the next line, which you can see. So, that is basically the bool and how the bool works and how the bool can be useful. It's generally just a truth value. So if you're going to create a code, you could create a variable called, true or whatever, or create a a bool true and and assign it to 1. Okay, and then you could create a bool false and assign it to 0, and then you could just say bool I equals true. These are just different ways you can make your code a little bit more, friendly to understand for yourself. And then I, is true. I guess I could even type it. I could type it that way, or I could type it I is equal to true. It doesn't matter. But these are just different ways that you can use a bool. Anyways, I got to cover something else real quick first before we end this video. I'm going to cover uint data types. So, different integer values. We've dealt with ints so far. Ints are supposed to be a minimum of 16 bits, but I found out in a previous thing that I did that they go up to a maximum of 32. It went up to 32 bits for me, but it will never go below 16. So, different bit types. First of all, we got to put a new directory because we just got to make things hard on ourselves here. It's going to be called standard int.h. And what this is going to allow us to do is take and declare different integer lengths. So uint, I'm going to go uint 8t. This is the smallest integer length that you can have, and I'm just going to call it y because I just couldn't think of anything else off the top of my head. Now I'm going to show you guys something. uint 8. This 8 here represents the number of bits that will be allowed to be stored in the data location. So it picks a data location that has 8 bits free, and it will store a num there. Well, 0 we can obviously represent no problem, guys. So, I don't know why I didn't name it I. But we can represent 0 no problem. Okay, there's 0. But also, the maximum number that's 8 bits is 255. It's represented by 8 ones. There's our 255. So you guys might be wondering, what happens if we go 256? How does that work? As you guys can see, it goes back to 0. Why does that happen? It has to deal with bit overflow. Now, I'm not going to go too much into this type of stuff because I plan on doing a logic course later in some of these tutorials, and you guys can watch my logic course tutorials, and you'll understand how that stuff works a little bit better. But we can also go 16, and now it's freed up again because we have 16 bits. And I believe I have the site open with all of the, you can specify, I believe, 8, 16, 32, and 64. So you can go up to 64 bits. So 64 bits, obviously, guys, would be a lot of numbers. And that's the maximum number size that your computer can store. That is somewhere probably in the, I don't even know. It is very high. It actually, on the calculator, the numbers will start to go negative when you use, because they got to have 32 bits, I believe, to represent the positive numbers, and then they start using the other 32 bits to represent negative numbers. So I guess the maximum positive number you can have, I think, is, oh man, it's really large. You guys will never need to go this far. I think it's in the quadrillions. So it's very large. These are just the different types of how you can specify bit lengths. Anyways, that's all I have for you guys for this tutorial. I just wanted to cover different vector sizes, and I will see you guys at the next tutorial.